Hi, this is King of Review. In this problem, we're asked to find the value of A plus B minus C. The values for A, B, and C are tucked inside these matrices here. So what we want to do is start by multiplying these two matrices together and then compare it with this matrix to find the values for A, B, and C. And then we'll plug those values into this expression to find our answer. So let's start by multiplying the first two matrices together. You need to remember that the product of two matrices is defined as long as the number of columns in the first matrix is equal to the number of rows in the second matrix. So let's look at this first matrix here. This matrix is a 2 by 2, and the second one is also a 2 by 2. So because these two numbers here are equal, we can go ahead and multiply these matrices together. When you multiply, you need to multiply corresponding entries in the first row of the first matrix times the entries in the first column of the second matrix, and then add these two products together. So let's set up the math for each of these entries. So our first entry is going to be 1 times negative 1 plus 3 times 0. So we have 1 times negative 1 plus 3 times 0. That's our first entry. Our next entry is going to be A times negative 1 plus 0 times 0. Moving on to the second column, we get 1 times negative 2 plus 3 times b. And our final entry is A times negative 2 plus 0 times b. So we've set up the math for this matrix, and now let's simplify this. This entry here, 1 times negative 1 plus 3 times 0, that gives us a negative 1. A times negative 1 plus 0 times 0, this gives us negative A. And next we have 1 times negative 2 plus 3 times b. This gives us negative 2 plus 3b. And our final entry, A times negative 2 plus 0 times b. This gives us negative 2a. Now, in the original equation that was given to us, we know that the product of these two matrices is equal to this matrix here. So we know that this is equal to the matrix negative 1, 1, negative 2, and c. Now, when we have two matrices like this, both of these are 2 by 2s. That's the dimensions. When we have two matrices of the same size that are set equal to one another, like these two are, we know that corresponding entries are equal. So the upper left entry, or column 1, row 1, is equal to the upper left-hand entry over here. And this is true. Negative 1 equals negative 1. So now let's set the other entries equal to one another. We have negative A is equal to negative 2. Negative A equals negative 2. Let's go ahead and solve for A here. This is the same thing as negative 1 times A equals negative 2. So we'll divide by negative 1 on both sides. And we're left with A is equal to 2. So now we know that this value here is 2. Let's look at some of the others. We have negative 2 plus 3b is equal to 1. Let's write that out. Negative 2 plus 3b equals 1. Let's solve for b. I'm going to start by adding 2 on both sides. I have 3b equals 3. Dividing by 3 on both sides, I get b is equal to 1. So now we know that b here equals 1. And now let's look at the final entry. Negative 2a equals c. Negative 2a equals c. Now we already know what a is. We solved for that back here. So negative 2 times a, which we found to be 2, equals C. Negative 2 times 2 is negative 4, and this is equal to C. So we know that C equals negative 4. So now we have all the information we need to find this expression here. A is 2, B is 1, and we're minusing a negative 4, which is C. This is 2 plus 1 plus 4, and this works out to give us 7. So 7 is the final answer here. Thanks for watching.